Hi, I'm thinking of doing Tetris for my final project, and so if you're not familiar, Tetris is this block stacking game where the objective is to get fill up lines of blocks and then clear them to get some points. So you'll see here, we clear a line, we get some points. Pretty simple premise. So let's take a little closer look at what specific implementation of Tetris I'm going to end up doing. So we're going to focus on a more classic version of Tetris where we only know the next tetromino. And I'm going to make some changes to the implementation where instead of being able to manually move the piece, the agent will just have to choose a column. So we won't allow for fancy moves that end up moving the tetromino after it's already reached the bottom. Basically, you just pick a column, pick a rotation of the block, and pick a column, and that's it. Now, one important thing about Tetris is that clearing multiple lines at the same time gives you a lot more points. So that'll be interesting to see what kind of techniques we can use to learn those strategies. So the techniques that I'm thinking about right now are tree search and approximate Q learning. So with tree search, we'll have to modify the standard algorithms to include the random event. But I think what's interesting here is that we can write a heuristic, I think. For Tetris, it might be interesting to try and write a heuristic that encodes maybe the number of holes, a hole being a place where you can no longer place a block, so that's going to be hard to clear that line until you clear some lines above it. Obviously you can include the score, maybe the height of the board so far, because you don't want to get to the top. If you fill up your board and get to the top, you lose the game. So that's your game over state. Tree search is one thing. Maybe we could do something like Monte Carlo tree search with some enhancements to use that domain knowledge that we have. One of the concerns is the large branching factor, though. So at each round, at each turn, I guess, of this turn-based Tetris that I'm going to implement, there's going to be 10 columns to choose from, up to 4 rotations for each block. So it'll be around 40, maybe a bit less, maybe like 30, but a branching factor of 30. And then, of course, you have to account for the random event that happens as well. 7 possible values for the next tetromino. So that will be interesting to consider. Another thing is, as your level goes up, the amount of time to decide where to place your block will go down. I mean, in standard Tetris, the speed of your falling block increases. So to deal with that in this kind of turn-based implementation that I'm going to do, we'll just decrease the time that the agent has to make a decision. So the tree search might initially have enough time to choose a good move, but later on it will start struggling, and that should mirror a human player experience. Now the other technique, Q learning, I think this is interesting because there's a lot of useful features to choose from, and the Q learning agent can keep learning throughout the game. It can keep training, keep running more and more simulations during whatever time it has to decide. The points that you gain nicely translate over to the reward. And then for feature selection, I've come up with a few that I think might be interesting. For example, obviously, the obvious ones are your current tetromino, next tetromino, maybe the board shape, stuff to do with the board shape. So maybe we look at the shape of the top row, which blocks are present in the top row of the board. The number of holes might be something to include here. Maybe something more advanced like the shape of the board near the action that you choose. So this would be a feature that depends on the state and the action. One of the most important strategies in Tetris is leaving an empty column at one of the sides to wait for an I tetromino, that's the long one, so that you can clear 4 lines at once. And I think that strategy might be difficult to learn, or it might be a challenge to try and get this agent to learn that strategy, especially with something like Monte Carlo tree search. Standard MCTS, at least, would have to get extremely lucky to ever discover that strategy, because it would take maybe 20 moves of perfect play randomly to discover that strategy is useful. So I might have to encode that strategy or knowledge of that strategy into the heuristic or into the feature selection somehow. We'll see how that turns out. We'll see if Q-learning or some modified version of tree search is able to discover that strategy. But so yeah, that's what I'm thinking about right now. Any comments, feedback, ideas, suggestions, questions would be welcome. Thank you.